Alright guys, welcome to today's class. We are going to be looking at the transformation of curve graph to linear graph. Okay, so we have seen that the linear graph is more easily analyzed compared to the curved graph. Okay, so we want to see how we can transform these curve graphs to be in the linear form so that we can easily analyze them and get the slope and intercept from the equation. Okay, are you ready? So let's go. Now, if we consider the first one, the parabola curve graph, we know that this is the form of the parabola curve graph, that y is equal to ax squared plus bx plus c. Okay, now if we want to do this transformation, now we can decide to move this c over to this side. Okay, then simplify these variables that we have here, x. Okay, so if we do that, we are going to have that this will be y minus c is equal to ax squared plus bx plus what? Plus c. Okay, so we don't write the c again because we have moved it over to this side, right? Okay, so if we factor out x here, we are going to have ax plus b, then we have y minus c there. Alright, so I will now divide through by x, so that what I will have is y minus c all over what? X is equal to ax plus what? Plus b. So now this is what we have. We are having y minus c all over x is equal to ax plus what? Plus b. Alright, so if you compare this with the equation of a straight line, okay, you see that your y is just corresponding to everything we have here. Then your m is equal to what? A, that is the slope. Then c is equal to what? To b. Alright, so we are having here that our y is going to be y minus c all over x. Okay, then our slope here will be equal to what? A. Then the intercept here will be equal to what? B, okay, or C. Alright, C is equal to what? To B. Alright, so the same thing, your x, that is this x here, will be equal to the capital what? X. Okay, so we have gotten our intercepts here and our slope there. Alright, so that is for the curve graph, how we can convert it. So what we have done here is that we have converted this into the linear form. Now we have specific cases of this parabola curve graph. So let us analyze them. The first one, we have case 1 or case I, where c is equal to 0. This means that if our c is equal to 0, then we are going to have just y over x, right? Equal to ax plus what? Plus b. So the equation will now be in this form. Alright. Therefore, case 2, when our b is equal to 0, so if our b is equal to 0, of course, then we have just y minus c all over x equal to ax, because here is now what? 0. Alright. So in that case, you can see that we are going to have that this is y minus c all over x is equal to ax, right? Because our b is 0. So if you cross multiply, this will be y minus c is equal to ax squared. Then our y will be equal to ax squared plus what? Plus c. So we have the equation to be in this form. Okay. Now if we also consider when c is equal to 0 and b is equal to 0, where c is equal to 0 and b is equal to 0. So what we are going to have now will be we have that our c is equal to 0, so we no need to write it again. We have x, then ax, and also our b is equal to 0, so we leave it there. Then you see that this will be y is equal to ax squared. When you cross multiply, you have y is equal to ax squared. So the equation will now be in this form. So what you can see here is that this is just like a vertical straight line where we don't have the intercept. Okay, the intercept is what? Is 0. Then we have the slope to still be our what? A. And it's as if we are plotting y against what? X squared. Alright, so that is it. Then the other one we have is the hyperbola curve graph. So for the hyperbola curve graph, we have the form to be in this. This is the general equation for that. Okay, so now what we want to do here is we want to simplify that equation and write it this way. Okay, so that it now looks like, if you compare to the straight line graph, we have it this way. Okay, so it's as if this is our y-axis, right? And everything here is our x-axis. So that the intercept we see here is what is our slope. Okay, in this case. Alright, so that's for the hyperbola curve graph. Then let's analyze the exponential curve graph. So for us to do this for exponential, we are going to take the log of both sides. So if we do that, taking the log of both sides, we are going to have that this is log y is equal to log c exponential minus kx. Okay, so from your logarithm law, we can write this as log c plus log exponential minus kx. So we still have our log y here. Okay, so let's say this is the natural logarithm we take. So this will be in this form. Okay, now what we want to do is apply the power law here of logarithm. Move this over to this side. Then this will be log y to base e is equal to log c to base e. Then this negative kx move over to this side. Here becomes negative kx log e to base e. Alright, so we know that log e to base e will give us 1 from the same base law. Here will be equal to 1. So if I rearrange this, I can write it as log y to base e is equal to log c. Okay, let's rearrange. So here will be minus kx plus log c to base e. Okay, so this is the form we have it now. This is just like your typical straight line graph. If you compare, you see that y is equal to this, the whole of everything that is here. That is your y. Then your slope, x is corresponding to this. Then the slope is just minus k. That's our slope, is minus k. Alright. Then the intercept here is just what everything that we have here. So you see we have been able to simplify this exponential equation to a linear equation, such that we can find our x, our intercept, and our slope. Okay, so this is just the transformation of the curve graph. So it makes it easier for us to analyze this curved graph. Okay, so we are going to stop here for today. So in our next class, we'll look at how we can find the error in slope and then the error in the intercept. Okay, so thank you.